Hello, my name is Veronica Castro. I am doing College Physics 1301, and I'm going to be doing an assignment video that we have to solve two equations, which is the application of Newton's law and energy. In our first problem that we have to, they're asking me, this picture hangs on the wall, suspended by two strings as shown below. And then the tension in the string 1, which is this one, is 1.7 Newton. And then it says calculate tension in string 2, which is this one. This is tension 2. And then we also need to calculate the picture, which is this, which is the mass with gravity. This would be considered tension 1, which is the 1.7. And then this degree was already given to us. And then we also had a missing angle, which is equal to 65, which is on this side, which is 65 degrees. Basically, to solve for tension, it's tension equals mass over gravity. We need to put the sum of forces for the x and the y axis, since we have the y axis and then the x axis right here. And we need to solve for the two parts, which is the tension in the string 2 and then the weight of the picture piece. So this is my free body diagram. This is my tension 1, tension 2, my two angles, my mass and gravity. And then to go ahead and solve the equation for the first part, we need to do the sum of force of f of x, which equals tension 1 cosine of the angle 1. And then it's going to be plus tension 2 cosine of the second angle, which equals to 0. We set up our equation. We need to solve for tension 2, which is this one. So this one we're going to put it to the side. We're going to put an equal sign. So what we are going to have left is going to be tension 1 with a cosine of theta 1. And it's going to be over cosine of theta 2. For the tension 1, we have the newtons, which is 1.7. The cosine of 65 degrees, which is this one right here. And then it's going to be over cosine of the data that we had, which is 32. And to solve that, we're going to get tension 2. And we have to solve it in our calculator. Basically, we would put 1.7 cosine of 65 divided by the cosine of 32, and it's going to be 0.847181956. We'll go ahead and round that off to 0.85, and this is going to be newtons. Okay, now we need to solve for the weight, which is going to be in the y-axis, and our milligrams and the grams are in the y-axis. So we need the sum force of y, which is equal to tension 1 sine of the data 1, and it's going to be plus tension 2 sine theta 2, and it's going to be minus w equals 0. We need to move the w to the other side of the equal sign, and these cancel. So our problem is going to be tension 1 sine of theta 1 plus tension 2 sine of theta 2 equals w. For tension 1, we have our picture, which is going to be the 1.7. So we put 1.7 sine of theta and our data is going to be 65. So we put 65, and then our tension 2 is going to be the one that we solved, which is the 0.85. So we're going to put 0.85 with this sign, and then our data right there is going to be 32. Okay, so on that one, we are going to calculate our weight. So we're going to grabbed our calculators and put 1.7 sine of 65, and then it's going to be plus 0.85 sine of 32. That's going to give us a weight of 1.99, and that's going to be in newtons. So our weight is going to equal 1.99 newtons. And for this equation, we were solving for the weight and for the tension. Our forces were given, one force was given, which was the 1.7. We had to find the second force, and our weight, we needed to find our weight. And for this problem, that is basically the steps that we had to do. This is actually following the physics concepts of Newton's second law. Basically, a body at rest will remain at rest unless acted upon. This would be for this concept right here. We're going to do our second problem, which our second problem basically it's considered energy. It says skateboarder starts at a point A in the figure and rises to a height h above the top of the ramp at point B. What was the skateboard's initial speed at point A? For the value of height h, look at the table below. Search for your last name. There was a table that was given. We needed to search for our last name. My last name is Castro, so I'm gonna use 2.20 meters for my height. And basically there's this is like a little ring. We have our 0.8 right here. We have our skater right there. We need our initial we're gonna need our initial speed, which is gonna be V1 or VI, sorry. That's gonna be our speed for initial. We basically have our point B is from right here for skater 2. This is going to be our height from here, and this is going to be point B. For this one, we have our initial height. It's right here. We have our initial height being 0. We have our final height is going to be the equation that I had to use from the table, which was our final height was 2.2 meters. So we're using the equation of conservation of energy in this problem. Basically, we have our initial height, which is 0. We have our final height, which is 2.2. We have our final velocity, which ends right here, and it's at rest. Since it's at rest, our final velocity is going to be 0. So our equation is going to be the change of kinetic energy equals the change of potential energy. And kinetic energy equals potential energy, which is kinetic is 1/2 mass with velocity, and it's going to be final equals 1/2 mass velocity initial squared. Our potential energy is mass times gravity times height. Our final equals, it's going to be minus mass times gravity times height initial So to put the two equations together, we're going to do 1/2 the kinetic energy first, which is the final, minus 1/2 of the initial. We're going to equal the final, and then minus the initial. Okay, so we have our final velocity, which is 0. So basically this part right here, if we multiply our mass times velocity, 2 times 0 is going to be 0. So we don't need this part. This is what we're looking for. We have our final velocity, our final height, which is 2.2. We have our initial height, which is 0. And again, whatever number times 0 is going to be 0. So we don't need that part. We're going to be left with 1/2, which is the initial velocity, with the final mass, gravity, and height. So we need to get, we don't have mass, we don't need mass. So we can divide our mass to both equations and we can get rid of that. So we're going to be left with 1/2 initial velocity squared, and then equal to gravity times height, which is our final height. To set up our equation, we have the 1/2 VI squared equals, which is our gravity is 9.8 times our height, that's what we have. We need to get rid of our 1/2, so we're going to go ahead and multiply both sides by 2. -2. And then these canceled, so we're left with velocity initial squared equals, we're going to do the -2. Our gravity is going to be negative since gravity is going down, so times -9.8. And then our height is 2.2. We get our calculators and we do -2 times -9.8 times 2.2. That will equal 4312. That's our velocity squared. We need to get rid of this squared on this side and put it into this side. In order to do that, we need to square root both equations. This cancels out and we're left with initial velocity. And then the square root of 4312 is 6.57. And then this is going to be initial speed, which is meters per second. This is going to be our final answer for the second problem that they were needing our initial speed. This concludes my presentation for both problems. Thank you.